Previously, I introduced you to the idea of how to use the periodic table. And so, why do we need to actually use that periodic table? Well, one of the most fundamental things that we need to do is use it to understand the structures of atoms. And there are several different theories that people use to develop over time what an atom looks like. And what we're going to learn about today is one called the Bohr model. Now, the Bohr model is not the most current model of the atom, but the one that is the most current is a little confusing. And so the Bohr model is a great starting point. It explains a lot about the ways that atoms work and combine together and do different things. And so for basic chemistry, it's really good enough. And so that's where we're going to start. But in order to do this, we have to know a few rules about how to use them because it helps us understand a little bit about that structure of atoms. So the first thing you're going to want to do is make sure you pull out your periodic table. And as you pull out your periodic table, we're going to go through an example about how to draw a Bohr model. And on your periodic table, I want you to find fluorine. So fluorine is in the 17th column, the second row, and it's element number 9. And so this should be what you're looking at is something similar to this. You'll notice just from the information, it's a gas. It has an atomic number of 9, and it has an atomic mass of 19. We're going to use all of that information to help us draw an atom of fluorine. But in order to draw this atom of fluorine, we need to find 3 things first. We need to find the number of protons. Now, remember, the number of protons, that's based off of the atomic number. So the atomic number for fluorine is 9, which means that fluorine is going to have 9 protons. 9 protons. Now, the next thing that we can find from that is the number of electrons. Now, I'm going to write electrons down here because remember, the electrons in an atom are the same as the number of protons, assuming it hasn't lost or gained any. And when we work off the periodic table, those elements we're just assuming right now they have not lost or gained any. So because it has 9 protons, it's also going to have 9 electrons. There's one last thing that we need to find, and that is the number of neutrons. Now, neutrons is not explicitly written on the periodic table, but remember from the last video, this number is the atomic mass. And the mass is actually the combination of both the protons and the neutrons. So to find the neutrons, we're going to take the atomic mass and we are going to subtract the number of protons. So for this atom of fluorine, that atomic mass was 19. Now, I should mention here, on the periodic table, it just so happens that this one is a number that doesn't have a decimal place. If it has a decimal place for now, just round it to the nearest whole number. So we have 19 neutrons. We need to subtract 9 protons. We're going to find that the neutrons are 10. Elements can actually have different numbers of neutrons. And so it is possible that you may see examples where it doesn't always work out to be what's on the periodic table. And that's because elements can be what's called an isotope. An isotope is just a different variety based on the number of neutrons. So I like to think, like I mentioned, they're all kind of like Legos, right? Each element is able to build and create other things, but each of those shapes of Lego comes in a different color. And you can kind of think of it the same way. Same structure, able to build the same things, but just a tiny little difference. And so when we do this way, where we just round the number from the periodic table, we're always going to get the same number of neutrons, but it is very possible that you can do this and get different numbers of neutrons because there's actually more than one kind of fluorine and carbon and hydrogen in every element. But for now, this is really all you need to know. So now that we know this information, we know our neutrons, we know our protons, we know our electrons, what we can do next is draw this atom. And so to draw this atom, we really need 2 parts. One is the nucleus, and in order to draw the nucleus, we need to put in the elements that are found in the nucleus. So the elements that are found in the nucleus, those are the protons, and those are the neutrons. So this is my advice for you as you write and draw your period or your atom. Draw the number of protons and neutrons first. So I'm going to put 9 protons, 10 neutrons, and then I am going to draw a circle around them. If you were to draw this circle first and then fill in your numbers after, I guarantee you're going to draw this circle way too small. You're just going to have to like crush those numbers in there. So now that we have that, the next thing we can do is fill in our electrons. Now, electrons go in rings that are called orbitals. And if you haven't done this in a while or have never done this before, then you might just think, okay, I'm going to draw my one ring, and I'm going to put all 9 electrons on there. Well, it doesn't really work that way. There are different rings, and each ring can only hold a maximum amount of electrons. So the first ring that I just drew can hold a maximum of 2 electrons. So what I can do is I can take my 2 electrons that can fit on this ring, and I can draw them in there. And I like to draw them as little e's with minus signs to show electron negative charge. But this orbital is now full. So here's what I'm going to do, is I'm going to add another orbital, so another ring. This is what would be called the second orbital. And the second orbital, you may think, okay, 2, next is 4. Yeah, it doesn't work that way. It's actually 8. The second orbital can hold a maximum of 8 electrons. And so what we're going to do is add our 8 electrons all the way around the outside to make it look like that. So this would be the electrons that it could hold. Now you may have noticed that I made a mistake here. I'm only supposed to have 9 electrons, and I drew 10. Well, we'll just erase one there, and there we go. So I've used up all 9 of my electrons. I have 2 in the first orbital, 1, 2, 3, 4, 5, 6, 7 in the second orbital. It is possible that you could draw a third orbital, which actually also holds a maximum of 8. We do not do this for the 4th, 5th, 6th orbitals. We don't draw a Bohr model because it really just doesn't work at that point. Now, there's something else important here, and that is this outside orbital. The outside orbital is called the valence shell. And it is the furthest outside orbital that holds electrons. And so if we wanted to talk about how many valence electrons were found in this element of fluorine, or in this atom of fluorine, it has 1, 2, 3, 4, 5, 6, 7 valence electrons. So even though it has 9 electrons in total, it only has 7 valence electrons. Later in the course, we're going to spend a lot of time talking about valence electrons because valence electrons are really what determines the way that an atom works. They're the furthest to the outside, so they bump into the rest of the world. And so the way that something behaves is actually ultimately determined by the number of valence electrons. So hopefully this helps you understand the structure of the Bohr model and the idea of having a nucleus in the center, multiple orbitals around the outside, 2 electrons in the first orbital, 8 electrons in the second, and 8 again in the third. If you have any questions, it's a great time to do some practice, ask if you need help, and make sure that you know this really well before we move on to the idea of ions. So thank you very much for watching, and I'll see you next time.